As it turns out, the absorption of light at 193 nanometers by water is more complex in the cornea. In fact, it's not completely understood, but may have to do with hydrogen bond breaking. A more thorough analysis of this phenomenon can be found in the journal article Dynamic 193 Nanometer Optical Properties of Water by Stave Teague and Walsh. In this article, the authors find that the 193 nanometer absorption coefficient of water was measured to increase by more than 5 orders of magnitude. What does that make the absorption coefficient of water compared to the value you used above? The question tells us that the absorption coefficient of water was measured to increase by more than 5 orders of magnitude. We used 0.1 centimeters to the -1 as the alpha before, and since the increase is 5 orders, this means it's logarithmic. And the new alpha compared to the old alpha is 0.1 times 10 to the 5th. Using this new absorption coefficient for water, in terms of percentage by how much has the intensity of light at 193 nanometers diminished after having traveled through the 0.6 millimeter cornea. To solve for this change, we'll use the equation I final over I naught equals e raised to the negative alpha times x. The percent will be I final over I naught. We are given that x equals 0.6 millimeters, and we know that alpha is now 0.1 times 10 to the 5th centimeters to the -1 from the previous question. We convert 0.6 millimeters to 0.06 centimeters. Plugging all the values in, we have I final over I naught equals e raised to the -0.1 centimeters times 10 to the 5th raised to the -1 times 0.06 centimeters. After solving, we see that I final over I naught equals 0. The question asks us how much the light intensity has decreased, so we subtract 0 from 1 to get 1, or 100%.